So last time we talked about the third method of solving systems of equations, solving by elimination. And in order to do that, we followed these steps. We looked for identical or opposite coefficients to a variable. And then if they were identical, we would subtract the two equations to eliminate a variable. If they were opposite, we would add the two equations. Either way, we eliminated one variable. Then we solved the resulting equation to find the value for one variable, and then substituted that value into either equation to solve for the remaining variable. Now, I mentioned when we were going through this that all the ones that we worked on that day had these identical or opposite coefficient pairs, right? We call them zero pairs. Today we're going to look at what happens. We're going to add a little step. How do you make a matching pair? All right, so you make a zero pair coefficient is the math way to say it, right? But it's identical or opposite. So make a zero pair coefficient. So we're going to add that today, and after this lesson, we'll be able to solve any system of equations because we have all the skills required. So another way to say that is, all we've done before, we solved equations when we knew how to eliminate a variable by adding or subtracting. Sometimes that's not possible. When it's not possible to just add or subtract, what you have to do is you need to multiply one or both equations by a new number in order to create a common coefficient. So what we're going to do today is modify one equation or two equations to make that common coefficient before we add or subtract to be able to continue solving. So let's look at how this works. So here's an example. If the instruction said solve the system using elimination, I look and I say, oh, there's a 3 and a 5. Those are not a common pair, so I'll look at y, and I see a 4 and a 2. There is no common coefficient in these equations. So this time, what I have to do is change one equation to create a common coefficient. So when I look at this, I see I can turn a 2 into a 4 pretty easily. All I have to do is multiply it by 2. I can't just change that number, but what I can do is multiply the entire equation by 2. So I multiply the first term by 2 and get 10x, the second term minus 4y, and the last term to get 36. The first equation I don't have to change because what I wanted to do was match up my y coefficients. Oh, I thought I wrote out 36. Maybe I just said that. Okay. Now when I look, I see a common coefficient. These y's are going to cancel. They have an opposite sign, so I will add them, and I get 13x equals negative 10 plus 36, 26. Go ahead and solve for x. X equals 2. I'm not done. I'm going to go up here and substitute it in, and I get 3 times 2 plus 4y equals negative 10. 6 plus 4y equals negative 10. So 4y equals negative 16. Dividing both sides by 4, I find that y equals negative 4. So I have an x value and a y value. I believe my answer is 2, negative 4. Just to make sure, I'm going to go ahead and double check. The top equation, 3 times 2 plus 4 times negative 4, gives me 6 plus negative 16. Sure enough, that is negative 10. I'm going to go ahead and check the second equation too because both have to be solved by the same values. So the second one, I get 5 times 2 minus 2 times negative 4, that would give me 10 plus 8 equals 18. And yes, that verifies this is a good answer. So you can see again, we followed all the steps that we did before when we were eliminating. We're just adding this preview step of creating a common pair before we do that. So these steps just show again what you do. You multiply the coefficients, you get the opposites, you add, solve for x, substitute to solve for y, check your solution. And here you go. You just get one additional step. You multiply by 2 to create a common coefficient. Now the fact is either variable can be eliminated when doing this. I'm going to use a common coefficient. I can pick which one is easier, but either one would work. So let's look at the same set of equations again, and this time look to eliminate x. If I see the 3 and 5, I need to know what number can I create that's common between 3 and 5. This is something we've done lots of times before in math. I want to know what's the least common multiple of 3 and 5. There are lots of ways to do this with prime factorization and others. Actually, there's usually these two ways to do it. Prime factorization or the table method. I see most students prefer the table method, so I list the two numbers, and then I start listing multiples. 3, and then 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15, 3 times 6 is 18, 3 times 7 is 21, and I'm just going to stop there. Then I'll go back and I'll check 5. 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, and that's as far as I have to go because I have found a number that is in both lists. Once I get to the first number that's in both lists, that's my least common multiple. So if I want to eliminate the x variable, I just have to make this least common multiple 15. In order to do that for the first equation, I'm going to multiply times 5 because 3 times 5 equals 15. So I'd get 15x, 4 times 5 is 20y, negative 10 times 5 is negative 50. For the second equation, I want a common multiple. I'm still going for 15. This time I only have to multiply times 3. 5x times 3 is 15x, minus 2 times 3 minus 6y. 18 times 3 is 54. So now when I look, these are identical coefficients. They're both positive. So I'm going to subtract the entire second equation. 15 minus 15 is cancel. 20 minus, there's my minus sign here, negative 6 gives me 26y. And negative 50 minus 54 is negative 104. Divide both of these by 26. And I get y equals negative 4, which is a good thing because that's the same answer I got previously. Just to practice, I could take this number back and substitute, and I would get 5x minus 2 times negative 4 equals 18. So 5x plus 8 equals 18. 5x equals 10, and x equals 2. I'm not going to double check again because this is the exact same answer we got before, but it does show you can eliminate by any variable, whichever one you prefer to use. So let's look at some equations and see which variable would you choose to eliminate. Now remember, there's no right answer. It's just looking at some possibilities of how you choose. When I look at this first set, I could eliminate by the x by making a common factor of 4. So to eliminate by x, I would multiply the bottom equation by 4. Okay. And then I would get 4x's and I would have to subtract. Okay. If I wanted to eliminate y, I could do that also. I see that there is a 2 and a 10, and the least common multiple is 10. So in this case, I would have to multiply again the bottom equation by 5. Right? So I could eliminate either x or y in that equation. And really for this red equation, it's indifferent. Whichever one you choose is about the same. When I look at these, the green set of equations, there's no very simple way. I can't turn a 3 into a 10. I can't turn an 8 into a 12. So I have to look for least common multiples. I note that there's a negative sign and a positive sign, and I think it's better. The better choice is to eliminate the y. Because eliminating the y, I have opposite signs. I don't have to worry about carrying the minus across. So I look, and I would see that the least common multiple of 8 and 12, the LCM is actually 24. So I would multiply the top by 3 and the bottom by 2. And when I did that, I would have a positive 24 and negative 24, and they'd eliminate each other. Okay. Similarly, when I look at this last set, which I'll go ahead and highlight in blue. 3 and 8, I cannot turn a 3 into an 8. 6 and 12, I can turn a 6 into a 12. So I would think again that the y is a better choice this time because I only have to multiply one thing, not two. And it also has a positive and a negative, which is an extra benefit. So the better choice is to eliminate y, multiplying the top by 2. Okay. And again, there's no right way to do this. You might look at 8 and 12 and think, oh, I can get those to 48. That's fine. As long as you don't make mistakes with your multiplication, your addition, your subtraction, any number you bring it to will be okay. The advantage of the least common multiple is that it keeps the numbers small, so you're less likely to make mistakes. So let's look at an example and see how we can solve it. In this case, 2 could be made into 6, 5 could be made into 20. I'm going to go ahead and eliminate the y, again, because I like the positive and negative sign pairing. So I'm going to multiply the top by 4, and I get 8x plus 20y equals 20. I don't have to do anything on the bottom. It already has the 20. 6x minus 20y equals 74. Right, these are going to eliminate when I add my equations. 8 plus 6 gives me 14x equals, I did not multiply this number by 4. This actually becomes 80. I made a mistake there. 80 plus 74 is 154. And when I divide 14 and 14, x equals 11. I'm not done yet. I have to go back and substitute, and then I would get 2 times 11 plus 5y equals 20. 22 plus 5y equals 20. So 5y equals negative 2. That looks kind of funny, but it is indeed the answer, negative 2/5. If you go back and check, which I strongly recommend you do, but for the interest of time, I am going to skip, you would see that this is indeed the correct answer, 11, negative 2/5. And let's look at one more example here. I can turn x into 6. I could eliminate the y's. My least common multiple there would be 24, but the least amount of multiplication is multiplying this one by 6. I would get 6x plus 18y equals 24. I didn't forget that time. 6x plus 8y equals 4. I have the same sign, so I'm going to subtract everything. The x's go away. 10y equals 20. Dividing by 10. I get y equals 2. I'm not done. I have to go back and substitute in. So I get x plus 3 times 2 equals 4. X plus 6 equals 4, so x equals negative 2. Again, I strongly recommend that you go back and check your answers like we did on the first problem, but the video is short, so we're going to stop there. So these steps, it's all the things we've already done and already practiced. We're just taking that initial first step to create a pair. And just like you saw with my mistake on this previous one, you have to be very careful when you're multiplying to make sure you multiply all the numbers across. Don't miss any, because that could be a place where it catches you. Checking your answers does help you catch those mistakes. But it is the same steps we were looking at before. You just need to multiply first. Once you have a common coefficient, subtract if they are the same sign, add if they are opposite signs, and then continue with the steps that we worked on previously.